Today's topic is dilations of points, segments, and lines. This is actually going to be a 2-day lesson, but you can put April 30th at the top of your notes. This packet is fairly large, so the first 4 pages look like this. And then the final 3 pages look like this. So just to start, let's review a dilation. We know when we dilate a point or figure, we are not preserving distance. The image that you produce is going to be similar. So I know it'll be the same shape, but it will be a different size. So instead of dilating a full figure, what if we just dilate a point with the center of dilation at the origin? Now, when we dilated a figure with the center at the origin, we were able to use a multiplication rule. So we're given point X located at 1, 3. I've also plotted the origin in yellow to make it stand out, and there's point X. So in our first dilation, we want to dilate about the origin by a scale factor of 2. So what we want to do is move point X twice as far from the origin. So what I'm going to do is examine the pattern. To get to X, I would have to rise 3 and run 1 to the right. To go twice as far, I need to run that same pattern again. We're going to rise 3 and run 1 to the right. So this is the location of X prime. My ordered pair is going to be 2, 6. We're going to go back to point X, and now we want to dilate it by a scale factor of 3. Notice they didn't put O for origin. It's assumed when no point is given that you are dilating it about the origin. So we're just going to keep going with our pattern. If I build off of X prime, I'm going to rise 3 and run 1. And this is the location of X double prime. And my ordered pair is 3, 9. Now you can see when we started with X, we're multiplying, in this case, to get to X prime by 2. And when we go to X double prime, we're multiplying by 3. So the multiplication rule does work when you're dilating about the origin. For our third example, dilating about the origin, but now we want to use a scale factor of -2 to get X triple prime. We're going to use the same established pattern, but instead I'm going to drop 3 and go to the left 1. When it's a negative scale factor, it places the image on the opposite side of the center of dilation. So we're going to drop 3 and run 1. That's only -1. We have to drop 3 more and plot the point right here. This is X triple. And its location is at -2, -6. And again, you can see building off of the original point at X, we multiplied by the scale factor to come up with our new location. For the next example, we're going to use the number line. We're going to dilate various points and we're going to change our center of dilation. So reading the information is really important. We're going to dilate using a center of dilation at A. So this is my center. We're going to dilate point B. What I want to know is how many blocks away are A and B. And it looks like if I count them, there's 4. We're going to use a scale factor of 3. So 4 blocks times 3 pushes it now 12 blocks away. So if we're counting, we've got 4, 6, 8, 10, 12. We're going to end up landing at point E. This time, in example 5, we're going to dilate. We're going to use E as the center of dilation. And we're going to dilate point F. So point F is 3 blocks away. And we're using a scale factor of -1. So this will place my image on the other side of E. But because it's a scale factor of 1, it will be the same distance away from E. So that will place us at point D. In example 6, we're going to dilate about point D. So D is my center of dilation. And we're going to dilate point E. Again, we're 3 blocks away. We're using a scale factor of 2. Because it's positive, it will remain on the right side, and we'll want to push it to 6 blocks away, and we're going to end up at point F. In our next example, we're going to dilate using a center of dilation at E, and we're going to dilate F. So we are 3 blocks apart. We're using a scale factor of -4, so we're going to push it 4 times 3, 12 blocks away, but the negative places it on the other side of E. So we were going to end up at point A. Now, what if we move the center of dilation away from the origin? How will that change the location of my new image point? So we're going to use point H at -3, 4 and a center of dilation at -8, 2. I've graphed the center of dilation in red and I've labeled point H. What we can do is use the same idea of a slope pattern. So in order to get from the center of dilation to H, I would have rose 2 and then ran to the right 5. So to move H twice as far away from the center of dilation at C, I will continue that pattern. So I'm going to rise 2, and I'm going to run 5. And this is the location of H prime. So our location then is at 2, 6. In example E, we're still dilating around point C, but now we're going to dilate it 3 times as far. So I can go ahead and build right off of H prime, and I'm going to continue that pattern of rising 2 and running 5. And this will be the location of H double prime. And our location is 7, 8. If we look at the center of dilation and all the points that were plotted, single prime and double prime, we can clearly see that all of these points do lie in a straight line. If you go back to the last example where we dilated about the origin, you'll also find that the center and all of the image points are also on a straight line. So that's going to lead us to some conclusions. Recall that it takes only 2 points to graph a line. So if you dilate a point, and we're also using a center of dilation, those 2 points have established a line for us. So when you take the center of dilation and your pre-image and you move its image point further away from it, you're creating a third point on that same straight line. So what we're going to have is the center, the pre-image, and the image all lying on the same line. If you apply this to the idea of a full line being graphed, if you had a line plotted and the center of dilation was actually on the line, so we had graphed line AB, and the center O is contained on the line, the dilation of it just pushes A prime and B prime farther from the center, but you're going to get the same line again. So the pre-image and the image will continue to be the same line. So because the center of dilation is on the line, the scale factor provided whether it's +2, +3, allows us to actually increase the distance from the center, and it moves it further away. But again, it's going to always be that same line. So what if we move the center of dilation off the line? In my picture, you can see that O is my center of dilation. I'm going to dilate line AB. So the first step is just like we did in yesterday's notes. I'm going to draw a line with my straight edge between O and A, and I'm going to keep that line going, extending it on. I'm also going to draw a line from O to B and make it go on. So if you just focus on moving the points further from the center of dilation, we're going to find their new location. So potentially here is A prime, and here is B prime. So we'll say that I did ×2. We can draw our line through A and B. And what you're creating now is another line that's been moved twice as far away from the center of dilation. So the conclusion that we're going to make here is, if you look at the center of dilation lying off the line, here's the original line, AB. What we did is we pushed A prime and B prime further from the center of dilation using the scale factor. In this one, it's 1.5. But when we go ahead and connect A prime and B prime, we've created an image that is now a parallel line. Both do not contain the center of dilation. So when you dilate a line and the center of dilation does not lie on that line, you will always create then a parallel line. So the scale factor will help you move the new image points, and it will show you how far it's moved from the center of dilation in relation to the pre-image. Here's a picture of a center of dilation. The green triangle, ABC, was the pre-image. It blew up to be the larger prime image, but you can see by connecting A and A prime, we could actually locate O, our center of dilation, if it wasn't known to us. And you would need a couple sets of lines to actually find that. Same thing is true here. We took our image, ABCD, or our pre-image, and we shrunk it down to A prime, B prime, C prime, D prime, without the center of dilation, provided we would have to draw lines to actually locate its position. This is tonight's homework, but the lesson itself isn't complete yet. So you can attempt as many of these problems as possible. When we complete the lesson tomorrow, we'll assign the rest of this packet, but I'm going to count this assignment as number 121 and number 122, and it's going to go in the grade book twice. If you have any questions about the lesson or completing any of the homework problems, please make sure you get in contact with me. Have a great day.